Okay, so our today's lecture is about artificial intelligence. How we gonna add something into artificial intelligence? So first of all, we have to find out how we gonna search something into the AI. Artificial intelligence is all about the AI and agents. How we're gonna plan something out of the path, how our application, how our things can find the path from out of nothing. So my concern is all about the agents, and in our today's lecture, we are going to talk about agent that plans ahead, search problems, what are the search problems, how we can solve the search problems. And search problems I highlighted is because it's a very important thing while working with artificial intelligence. It's a very important thing how you're going to find out what is your problem, how you're going to solve the problem, and how you're going to find the problem first of all. So for finding the problem, we are going to have access with some uninformed search methods, in which most of you have heard about the depth first search, the breadth first search, and the uniform uninformed cost search. So basically, we are going to discuss the depth first search and the breadth first search together because it's totally relate with the path finding and the path communication as well. While talking about the uninformed cost search, so it's more about how we're gonna add something in our research, in our search parameters, and how we're gonna find those parameters according to our situation. So let's talk about first, then we are going to have a heuristic search method as well. So let's talk about the agents first. So according to a lot of researchers and a lot of research papers while working on an AI, agents are those things which help you to promote your algo, which help you to find the solution according to your given problem. Now, an agent works with, like, this is the agent. If I must say, this blog contained the agent sensors and actuators, and it perceives something from the environment, and then it convert that something into an action. So agent can perceive and act. Definitely it's gonna perceive something from the environment, then it's gonna act on that environment as well. So agent can perceive something and act accordingly. Then select action that maximize its utilities function. So what are the utilities function? While working with the AI, you need to concern about something that is very unique, that is very specific, that is very common. I must say the common in the sense that you can create that environment easily, but you can get the results in complex way. So always agent has a goal with it. Your agent is always have some goals to achieve, to some get something out of that part. So it basically attached to some questions and some precipitance part of everything. So basic agents have some goals that depends on the environment, and that environment can perceive the information from the input and output towards the agent. Now our agent can help in a lot of ways. How? Now agent, if I talk about the search problem, agent can help in very different ways. While in searching, the environment can set itself on fully observable, single agent, deterministic, static, or discrete. So it's all about the environment perceiving the agent from all around the globe. So it depends sometimes, and sometimes it's not. So while taking an example of the reflex agent, agent is like to finding a new path according to the given situation. While talking about the Pac-Man game, which was designed way back in 90s. So Pac-Man had to be designed to solve a mystery in just box. So reflex agent can help to choose the action based on the current concept and the memory as well. So this current situation, the current box is the memory situation. This box is memory for this Pac-Man. Now the Pac-Man have to get rid over each and every dots so he can consider itself a winner. So do not consider the future consequences of their action. While sometimes it happens while you're working on a Pac-Man and some kind of agent. So while you're doing something right now, it doesn't matter that you can perceive the better result on in future. It doesn't happen. It doesn't consider itself. It doesn't have to make itself right way. So how are you gonna act as an agent in the real world of IS? Reflex agent can help us. Maybe it can help us to achieve our goals, but how that agent can help us? If we are going to talk about the Pac-Man and taking this example as our concern, do you think this Pac-Man will able to get all the dots at the same time at the same pace without any ghost, without any viral material, without anything else? No. While taking down these dots, Pac-Man have to cross the ghost. Pac-Man have to cross the different scenarios, different parameters, different things. So what is going on with the stuff? It always plan ahead. Ask what the CN is based on. So it's the CN based on always on a hypothesis, which means hypothesis or hypothesized consequences of that action. Sometimes it happens that you are working with a lot of things. Your consequences is totally different with your stuff. So how are you gonna make it happen? How are you gonna make it correct? Because if you are talk about the consequences, then it happens while you're going to take care of your models as well. Now, talking about your models, agent can help to create a better model, must have a model how the world resolve and responds to the actions. It means the agent have the model that help you how the world can work on it, act on how the world would be. Yes, definitely, when you are going to have a solution from your agent, and that agent can help you to find a better solution, to develop a better solution, and to get the better solution out of that thing, which means your agent can know a lot of things accordingly. So your agent can have things accordingly. So agent can resolve the problem that would you gonna face. Like how? So while talking about the search through a problem space or the state space, if I'm going to talk about what is state space. If I'm going to say the definition of state space, it's totally like the disparity between the initial state to the final state is a state space. The disparity, the difference between your final result and towards the initial result, the difference between the initial and the final, that is your state space, not your problem space. Now, while talking about the problem space in between your solution and your wrong answer. If I must say, your solution is that way you're going to get something to be resolved. But while working in a problem space, you're going to have a lot of solution. You're going to through a lot of small solutions, small solution size. So it depends on your state space as well as your states. So while talking about the state space, before the problem space, you need to set the states. You need to have a set of states, in which you're going to create some kind of random models. Now, your model can be a successful and your model cannot be a successful model. So it always depends on your model capabilities. Now, what are your model capabilities? So it depends on your model and the things you're going to create. So basically what you are going to have in your model capabilities, that you have your start space. When you have your start space, it means you're going with the successor function or not. If you're going with the successor functions, which means you're going to achieve your goal state. If you have a successor function, once again, then you are going to achieve your goal state. How are you going to achieve your goal state? And you're going to start from the initial state, in which your state space have a size with number of 0. Now, what will be the output? What will be the outcome of this thing? While searching in the state space, or while searching on something, your output will be on your path that starts, states, satisfying goal test. You're going to test your goal and may requires the shortest path. So it depends on your shortest path, and it depends on what path you're going to have. And sometimes you just need state passing test. So that's most common thing, that state passing test. While I'm going to take a little bit small example of the Pac-Man as well. Once again, input states has some spaces between the Pac-Man and the dots he's going to eat. So every state have a unique position in these parameters. If you look at the parameters of the Pac-Man, so each and every state have a unique combination of everything. Every state have a unique combination of things that is going to be happen in the parameters. So what is the successor function actually then? Successor function, when your Pac-Man is going to eat something that will be successfully eaten. So fact of the problem is, when your Pac-Man is going to eat something and it's going to be happen correctly. So it shows that you're going to have a start state here and your goal state here. Like, you're going to have nothing on your board, just eaten by the Pac-Man. So now what will be the output? How that Pac-Man is able to find the search space. So output would be like a tree-based something. Like this is a routing path from Romania. So Romania and from the Bruchet. So it depends on your states. How many states do you have? How many states you are going to have? So while talking about another example of n queen. So it's also gonna have states. In this example, we always talk about no queen can cancel the effect of each other. So there are a lot of examples like algebraic simplification. Each and everything have a state space. As I told you about before, a world states include every detail of the environment, while the search state include the only details needed for planning, problem pathing, and problem eat all dots. As I told you before, the Pac-Man has to eat each and every dot, and he has to avoid the ghosts. So it depends on your state space. How much state space do you have? So according to this Pac-Man, this is your initial state, and this would be your last state. And you're going to eat each and every dot from this board. At the starting, your Pac-Man is your initial state. So this will be your goal state. Dots all false. Now, the state space size depends on how many position do Pac-Man going to have and how many position and counting of dots the Pac-Man is going to eat. That's your space size as well. So you can calculate many space sizes accordingly, And there are a lot of things as well. So states of all 18 dots is 120, the world state, 2 raised to power 30 dots, 2 ghosts into 4. So it's basically the formula: up, down, right, left, food counting, and the ghost positions. So it always count at the world state, and when you're going to talk about the 18 dots, it's 2 raised to power 3, 30. It varies always while you are going to have a state space in it. It always vary. It always vary when you are going to have the state space in it. What if, we are going to talk about the trees later. Okay, I guess we have to talk about it right now. Okay. So while you're going to have a state space and trees, then you have to make a search tree in which you're going to find out which path you have to follow, right or left. Right would be the shorter or left would be the shorter. So you have to calculate the knots, like how many childs do these trees have, how many childs do these three have. So this is about the search tree. How are you going to find out your initial state, your starting state towards the goal state? So what path you're going to find? What path are you going to have? So you're going to design the path always be like this one. When you're going to have a path, it always shows the smallest path, the smallest distance. So it's now your assignment that you're going to have to find out or make a tree like it. You have to find out what will be the shortest path for this one.